Hello, we are going to be making appropriate scatter plots in this screencast. And our lesson target, our learning target is I can identify the most appropriate scatter plot to display a set of data. So you need to have a good sense of this prior lesson, which was just constructing scatter plots in general when everything was pretty much set up for you. And in this lesson, we're going to talk about how to make everything appropriate when not all of the information is given. And we use this for the line of best fit. We use this for correlation coefficient and for describing trend lines. So in order to select this correct scatter plot, we need to consider two different pieces. One of them is that you have a reasonable scale on both axes. And of the two requirements, this one is not as bad. What I do want to focus on is talking about the explanatory variable on the x-axis. And I want to talk about what that explanatory variable is and its counterpart, the response variable. So basically, when we're looking at an explanatory variable, we can sometimes call those the independent variable versus the dependent variable. It's just that when we're looking at a scatter plot, we have different vocabulary. Another way to think about the predictor versus the outcome. So if this is the variable that I want to predict, then what is the outcome? So it's like if I want to make sure that I'm getting an A on my paper, how many hours should I be writing? So what would be the predictor, the number of hours that I write? We also just basically call them input and output. But the key thing to remember here is that the explanatory variable is on the x-axis and the response variable is on the y-axis. So there's a lot of different vocabulary that goes into figuring out what's the input and what's the output. So let's take a look at this situation. The hurricane hunters want to predict the wind speed of a hurricane based on the air pressure. So if I want to predict something based on something else, I want to do this based on the air pressure. That means I know the air pressure. And I need to know what should the wind speed be. And because it's something that I know or something that I want to use to make the prediction, if it's based on air pressure, then the explanatory variable is the air pressure. That's the variable that I am going to use to determine my response of wind speed. So in this case, and your keywords here are based on. If it is based on something, that's your explanatory variable. And then your response variable would be like your output or the one on the y-axis. So that's just one example of telling the difference between explanatory variable and the response variable. So let's now take a look and make this just a little bit bigger. So we're going to take a look at making it bigger. And again, we need to both consider the responsible scale or reasonable scale on both axes. And then we also want to make sure that the explanatory variable goes on the x-axis. So let's take a look. So the Clark County Commissioner wants to predict the number of marriage licenses based on the year. And then it gives us some information here. So just because this lesson is trying to teach us which is the response variable and which is the explanatory variable, I'm not going to trust that my top line is the X and my bottom line is the Y. I can't trust that in this lesson. 9 times out of 10, out in the real world, yes, they put your x-axis in the top line or over on the left, and they put your y-axis on the bottom one, which is the one on the right. But just because they're trying to teach me this lesson, I'm not going to make that assumption. And what I need to realize is that if I want to predict the number of licenses based on the year, then it turns out that the year is going to be my x-axis. That's my explanatory variable. And because I want to make a prediction using the year about marriage licenses is going to be my y-axis. And that's how these work. So in this lesson, you can't trust that they're going to set it up for you correctly. You have to really have a good understanding of which axis is which. Okay, so now I'm going to show you two different graphs. Both of these scatter plots are correct. They're 100% correct. If you were to look each coordinate, 1 comma 142, 6 comma 123, all of those are correct. But one of them is going to display the data best. That's what we're talking about with that other rule. The other rule was talking about which axis is more reasonable. And actually, we're really just looking for which graph is more clear. And if I had to choose between the left and the right, which graph is more clear, I would definitely pick the one on the left. So I would say this would be the most accurate scatter plot. I make sure that my year is in the x-axis, my marriage licenses is in my y-axis, and that my graph is clear, it's spread out, it's easy to read each point. And there you go. So that is how we identify the most appropriate scatter plot to display a set of data.